All right, if you would please find your textbooks, and we're going to open up to page 114. All right, we're going to open up our textbooks to page 114. All right, we're looking at the getting started. Is it proportional? And we're going to skip number 1 for now. We're going to go over to number 2. There it goes. All right, so for number 2, there are 250 boys in 6th grade, 75 are in the band. There are 200 girls in 6th grade, and 60 are in the band. Okay. Let's see. It says up here at the top, analyze each table to determine if the relationship is proportional. If the table represents a proportional relationship, state the constant ratio that exists between the corresponding values of the two quantities. All right, so I need to create my K column. 2 seconds. Let's see. All right, so I need to create my K column. All right, and we need to remember that K is equal to Y over X. All right, and when looking at my K column, right now I see a table and I've got boys versus girls and I have total versus band. Okay, remember, unless we are told, we are always going to make the left column X and the Y column is the left. So the first column is X, the second column is Y. So for this one, I'm going to do 75 over 250. I'm going to set that equals 2. Okay. And then I'm going to do 60 over 200. And set that equal. All right, so I'm going to hand out my handy dandy calculator, and I'm going to do Y divided by X. So 75 divided by 250, I get 0.3. And 60 divided by 60 divided by 200, and I should get 0.3. Okay. All right, let's find our K column for number 3. So commuters in McKnight and Mitten Ridge either drive to work or take the public transportation. Okay, so I need to find out my K column. And we're going to remember that K is Y over X. The first column is X, second column is Y. So I'm going to have 120 over 175, 300 over 525. And we're going to use our handy dandy calculator again to get, let's say, 0.686. I don't think this one's going to be proportional. Nope. 0.571. Well, I got 2 different numbers, so they're not proportional. And we can even tell that the number of driving to work versus the number of transportation, they do not go hand in hand. Okay? They do not go hand in hand. All right, now that we are warmed up with our K column, let's look over on activity 2.1. So we're on page 116. All right, in a proportional relationship, the ratio of Y values, okay, the ratio of all Y values or outputs to the corresponding X values or inputs is constant. The specific ratio of Y over X is called the constant of proportionality. So Y over X is known as the constant of proportionality. Generally, the variable K. It is used to represent the constant of proportionality. Okay, so let's revisit the television show scenario. And this situation represents a proportional relationship. So I notice that I have total program length in minutes, actual program show, and then the commercial length. Normally, we see tables that are represented in 2 columns versus 3, but for this scenario, we are going to only use, we're going to cross out commercial. We're only going to use the total program of X in the actual show of Y. All right. Okay, so identify the input and output quantities of the scenario. All right, let's go ahead and get our K column here. And remember that K is Y over X. All right, so I would love for you guys to take just about a second here, and I want you guys to create your K column for me. And we're gonna have 22 over 30, and then 88 over 120. And we're going to have, if you want to get it into decimal, is 7.3 repeating, or 0.73 repeating. Okay. All right, so suppose you want to determine the actual show lengths of your favorite television show without commercials if you know the total program length. Identify the input and output quantities in this scenario. All right, well, my input, these are my X values. Okay, my input are my X values, and those are 30 and 120. Okay, representing my total program length. My output is my Y values, and those are 22 and 88. Okay, so my input is 30 and 120, and my output is 22 and 88, which are my Y values. So to determine the length of the show without commercials, you will need to multiply the total program length by a constant of proportionality. So that would taking 30 and multiplying it by this number of 0.73 repeating to get to the actual show minutes. Okay. All right, so analyze the different ideas for determining the constant of proportionality. All right, so we're not going to mess with Susan today. So we're just going to mark Susan out for a moment. And we're going to look, we've got Jeremiah, Keisha, and Jamie. All right, so Jeremiah, we want to know the actual show length, and we know that the total program length. So we're going to say K is equal to 22 minutes of show over 30 total minutes in length, okay? Which is what we found for our K value here is 22 over 30. So Jeremiah did the same thing, where he simplified 22 over 30 into 11 over 15. Okay, he noticed that 2 can go in above 22 and 30 and get 11 over 15. And we can sit here and see 11 over 15. That's still our same decimal number. Okay, Keisha said this: to determine if a proportional relationship exists, the order of the ratio doesn't matter. So the constant of the proportionality can be 15 over 11, or K is equal 11 over 15. Well, let's take a second here. So when we did our K column, we found that it's 0.73, okay? And we see 11 over 15 is 0.73. If I do 15 over 11, look what I get. I'm going to get 1.36. So let's just take it for a second here. So I'm told, okay, I am told that if I take 30 and I multiply it by 11 over 15, which is our K value, I should get 22, which is true. What Keisha is saying, I can sit here and I can flip that number, my ratio, and it doesn't matter. So I flipped it. All I did was take the reciprocal of it. Let's see. Well, wait a minute. I'm supposed to have 22. Now I have 41. So the order does matter. Okay, so that's why Keisha is wrong. The order of the ratio does matter. And then let's take Jamie. Jeremiah is correct about which numbers to use, but he has them mixed up. The constant of the proportionality is K is equal to 30 over 22 or 15 over 11. Well, we just said that Keisha is not correct. So Jamie, he's only correct by saying Jeremiah is correct. But as far as mixing them up, no, we cannot mix them up. So number 3 is asking, explain why Jeremiah is correct, but Jamie and Keisha are incorrect. Well, we just said that. We said that Jeremiah used his proportion correctly. Whereas Jamie and Keisha flipped the proportion. I'm going to abbreviate. Making the statement untrue. Okay, making the statement untrue. All right. Let's look at another one here. All right, so the meaning of constant of proportionality. In 1972, the federal government passed Title IX, a law requiring educational institutions that receive federal funds to provide equitable athletic opportunities for all students, regardless of their of who they are. One of the requirements for compliance of Title IX is for institutions to provide opportunities for each subgroup that are proportional to their rates of enrollment, or to show that they are working to increase such opportunities. Similarly, athletes of different sexes are to receive athletic scholarship dollars proportional to their subgroup's participation. So let's think about the implications of Title IX at Vista Middle School. There are 5 girls for every 6 boys enrolled in Vista Middle School. Okay, so set up a proportion for each question, then solve each proportion to determine the unknown value. Use the information from the given ratio. All right, if there are 300 boys enrolled in the school, how many girls are going to be enrolled? Well, I know that I have 5 girls for every 6 boys. Okay, I know that I now have 300 boys. How many girls do I have? Well, I know that I'm going up from 6 to 300. So let's see, what did I multiply 6 by to get to 300? So I divide and I see that I get 50. So 6 times 50 gets me 300. And then I'm going to do 5 times 50. And I should see there are 250 girls. Okay. If there are 325 girls enrolled in the school, how many boys are there? So I know the number of girls, so let's use 5 girls again over 6 boys. I know 325 girls. How many boys? All right, so I'm going to go from 5 to 325. So then let's divide. I see that it's times 65. What I do on bottom, I have to do on top. So 6 times 65. There should be 390 boys. 390 boys. Sorry. All right. Define variables for the quantities that are changing in this situation. All right, so I'm going to say B is going to equal boys and G is going to equal girls. Those are my 2 variables that are going to be identified because those are the 2 different things that are changing consistently, either the number of boys or the number of girls. Okay. All right, number 3. Set up a proportion using variables for the quantities to the ratio given for the enrollment of girls and boys. All right, so I know that I have 5 girls to every 6 boys. Okay, and we can set this equal to G girls or B boys. Okay, because we're finding either one of those. We're not sure which one we're finding until we know what we're looking for or what we have. All right, so use your proportion and write an equation to determine, there we go. Write an equation to determine the number of girls enrolled at Vista Middle School if you know the number of boys enrolled. All right, so I need to find out, I need to take my proportion here, okay? And I need to rearrange it to figure out if I know the number of boys to find the number of girls. Okay, so I want to get G by itself. All right, not B. I want to get G by itself. All right, so it's going to look something like this. We can do 5 over 6 is equal to G over B. Okay, girls over boy. My goal is to get G by itself. So right now I need to do the opposite of what I see. Right now I'm dividing by B. So I'm going to multiply by B on both sides to get G left on one side. And then now I have 5 over 6 boys. 5 over 6 boys. Okay. It's asking, what is the constant of the proportionality in my situation? Where is the constant of proportionality? Well, I have G is equal to 5 over 6B. We are used to seeing our equations written as y is equal to k times x, or y is equal to a number times x. Well, this is written in the exact same format as this. All I did is just change the y for G and the x for B. So what is my constant of my proportionality here? And that is 5 over 6. All right, and what does the constant proportionality mean in the problem? It means the ratio of girls, okay, to the ratio of number of girls to the number of boys. Make that mathematically sound right. Okay, the number of girls to the number of boys. All right, and then let's look at one more very quickly. One more. So this one, I've flipped over to page 121 here. All right. So sometimes the constant of proportionality is not a whole number. The constant of proportionality can be used, can also be a decimal or a fraction, which we just saw. When the constant of proportionality involves whole items like people, it may seem strange to think of the constant of proportionality in terms of a fraction. Instead, you can think of the constant of proportionality as a way to predict the outcomes of a situation. All right, so here's your equation and the information about Title IX to answer the questions. So I'm going to rewrite my equation. So we just found G is equal to 5 over 6B. That's the equation that we just found. So if there are opportunities for 79 boys to participate in athletics, how many opportunities must be available for girls? All right, so I'm going to have G is equal to 5 over 6 times 79. Okay, we can rewrite this as 5 over 6 times 79 over 1. All right, get my handy dandy calculator. 5 times 79 is 395 over 6. And I'm going to take 395 and I'm going to see how many times can 6 go into 395 to get 65. And 5, 6. So roughly 65 girls can participate. Just think, we can't have half of a girl. So roughly 65 girls can about participate. Okay. All right, if you have any questions, please let us know.